For months, 3I Atlas was viewed as little more than a curiosity, a peculiar interstellar guest, certainly, but one we could categorize as a comet and move on. That narrative, however, hasn't survived its encounter with the data. Observations from James Webb, Hubble, ground-based telescopes, and even a deep space probe have all pointed toward the same unsettling conclusion. This object is behaving unlike anything we have ever witnessed. It is smaller than we expected, brighter than predicted, encased in a shell of gas and dust, and actually changing as it approaches Jupiter when it should be doing the exact opposite. Even more disturbing is the possibility that it isn't traveling alone. Something appears to be accompanying it, something that doesn't evaporate, doesn't accelerate in the same manner, and simply refuses to fit our current models. NASA maintains that more data is required, while scientists note that the mystery is only deepening. What Hubble and James Webb are now uncovering forces us to confront a question that sounds nearly unbelievable but can no longer be brushed aside. What exactly is 3I Atlas? As more accurate orbital data came to light, a subtle but haunting detail emerged. According to the JPL Horizon system, 3I Atlas doesn't act like a typical irregular or spherical comet nucleus. Instead, its motion and light curve suggest a teardrop geometry, a shape that naturally causes asymmetries in how it reflects light and releases material. That alone would make it a rarity, but the real shock arrived when researchers noticed other objects seemingly traveling alongside it. These companions don't sublimate, they don't exhibit standard cometary behavior, and crucially, they don't share the same non-gravitational acceleration as 3I Atlas itself. In simple terms, something is moving with it, but not as part of it. This isn't just debris scattering randomly or material breaking apart. It appears persistent, stable, and coordinated. This has forced researchers to reconsider whether this is a lone object at all, or a much more complex system traversing interstellar space. Then came the observation that truly shook the community, a repeating pattern of brightness measured with incredible precision, occurring every 16.16 hours. Not roughly, but exactly. This wasn't a metaphor. It was hard data published in Astrophysical Studies. 3I Atlas seems to pulse, dimming and brightening in a rhythm so steady that some have called it a cosmic heartbeat. The most conservative theory is rotational modulation, a spinning nucleus exposing an active patch to the sun, but even that fails under close inspection. The timing, the regularity near its Earth approach, and the way the pulse interacts with its surrounding material suggest something more structured than a random patch of ice. Whether this reflects internal processes or something even more intricate, one thing is certain. This object is not passive. When Hubble aimed its wide-field camera at 3I Atlas, the result might have looked unremarkable to a layman, but it was a gold mine for science. By tracking the object's motion rather than the stars, Hubble revealed a nucleus only 5.6 kilometers across, much smaller than previous guesses, wrapped in an enormous, bright coma and a tail spanning thousands of kilometers. This immediately signaled a problem. A nucleus that small shouldn't be able to maintain such intense activity for so long, yet it was growing brighter as it moved toward Jupiter. Hubble also confirmed a slight non-gravitational acceleration consistent with outgassing, but it was far too weak to explain the behavior of the surrounding swarm. Essentially, part of the system reacts to forces that the rest ignores, a split behavior that shouldn't exist in a normal comet. Meanwhile, deep space instruments captured a detail that couldn't be ignored: two distinct tails, one dust and one plasma, structurally separated and clearly visible. This indicates intense activity, with ionized gases hitting the solar wind while solid matter escapes. But the detail that truly breaks the model is the anti-tail, a sunward-facing, luminous teardrop pointing directly at the sun after perihelion. In classical physics, this shouldn't happen in a stable way. Yet, there it was, backed by calculations showing a tiny but consistent force acting on 3I Atlas that decreases with distance, much like solar gravity. The implication is simple yet unsettling. The main object is receiving an extra push that the surrounding swarm is not. This difference in acceleration creates a stable anti-tail made not of gas, but of countless small bodies reflecting light. We're no longer just looking at a comet. We are observing a system. As tracking continued, it became impossible to overlook the entourage. Images show a swarm of objects moving along its path, objects that don't fragment or evaporate. This rules out loose gas or dust, which would disperse. Instead, these companions remain organized and coherent. This is a massive problem for traditional models because a shedding comet should leave a chaotic trail, not an orderly group. What we are seeing looks like a system releasing solid components that behave collectively, creating optical effects powerful enough to dominate what telescopes see as the coma. This is where the mystery sharpens. The sunward anti-tail isn't a typical dust structure. It's a stable, teardrop shape that always points toward the sun. Calculations reveal that while 3I Atlas is subtly pushed, the swarm lags behind, forming a dense, reflective mirror of solid objects. This tricks our instruments into seeing an impossible structure. The scale here is deceptive. Models suggest a swarm of trillions of tiny fragments could reflect up to 99% of the light we see. Individually invisible, together they create a luminous illusion. This explains why amateur photos often look more dramatic than Hubble's. Different tools see different parts of the same phenomenon. The terrifying possibility is that we aren't even seeing the object itself, but rather its shielded entourage. At this point, scientists have entered uncomfortable territory. While the conservative view is that these are just rock and ice fragments released during perihelion, that only works if we assume 3I Atlas drifted for billions of years without hitting anything that would tear such a fragile structure apart. More speculative ideas wonder if the swarm's organization implies something we don't yet understand, perhaps material from a larger, differentiated body. Regardless, the conclusion is unavoidable. 3I Atlas is shedding objects, and those objects are rewriting the rules. Of all the anomalies, none is as haunting as that 16.16-hour pulse. It isn't noise or a fluke, it's a rhythm embedded in the object. While rotation is the easy answer, the pulse modulates the entire coma and interacts with the jets in a way that suggests a controlled cadence, almost like breathing rather than random eruptions. Furthermore, many of the jets remain sunward and don't sweep across space as the object spins. This suggests internal activity, something beneath the surface releasing energy. Comets don't have internal engines, yet 3I Atlas seems to react to the sun while also sustaining its own processes. This dual behavior is incredibly rare. When James Webb provided infrared data, the mystery only grew. The composition is dominated by CO2 and complex organics, differing from the water ice-driven comets of our solar system. This suggests it formed in an environment far colder and more stable than ours. Webb also confirmed the energy for the jets comes from deep inside, reinforcing the idea of an internal structure. This led to a radical hypothesis. What if 3I Atlas is a fragment of a differentiated body, like an exoplanet or exomoon, torn away from another star system? This would explain the internal activity, the pulses, the unusual chemistry, and the solid swarm. It could be hosting cryovolcanism, ice volcanoes powered by internal chemistry rather than solar heat. Its similarity to pristine meteorites hints at a metal-rich interior. If true, 3I Atlas is a literal piece of another world, carrying a record of distant processes. Ultimately, these oddities, the pulse, the swarm, the anti-tail, the chemistry, aren't contradicting each other. They're converging. 3I Atlas isn't a passive ball of ice. It's a coherent system. The introduction of cryovolcanism explains how it can stay active long after perihelion and why it ejects solid fragments. It isn't a conventional comet or a spacecraft. It's something more unsettlingly normal, a natural relic of an exoplanet. The final picture is humbling. 3I Atlas is a sample, a naturally delivered piece of another planetary system. It proves that planetary material can survive interstellar travel and awaken around a new star. It expands our map of the galaxy to include wandering relics and fragments. We arrive at a conclusion simpler and more profound than expected. 3I Atlas isn't a mystery because it's alien or breaks physics. It's extraordinary because it shows that fragments of other world can travel between the stars. It carries the fingerprints of a distant home. As it fades back into the dark, it leaves us with a shift in perspective. The universe isn't a collection of isolated boxes, but a dynamic system that occasionally delivers a piece of a distant world right to our door. The next time a visitor appears, we won't just ask what it is. We'll ask which world it came from. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.